Hey scholars, I hope you're doing well today. For today's lesson, we are going to discuss composite functions. We're going to learn a new notation and we're going to practice how to make composite functions. Basically, we're just combining functions in a different way than what we saw the other day. And we'll also learn how to evaluate them. So make sure you're paying close attention and taking good notes. Let's get going. Alright, so let's talk about the composition of functions. The result of a composition of functions is what we would call a composite function. And so to know that you're going to do a composition of functions, you will see a notation. You would read this as f of g of x, okay? Read this as f of g of x. You can just look at this little symbol and that's going to mean of. So f of g of x. And you can write that in another way. You may see it notated as f of g of x. You see, we're used to f of x, right? Or we're used to g of x. But here, we're taking g of x and we're substituting it into f of x. We're putting a function inside of a function. So this is going to seem maybe a little weird at first, but let's get some practice with it and try to understand it. Here's an example real quick. Here we have just some x values, okay? And we have f of g of x. We're trying to figure that out. So what we're going to do is take those x values and substitute them into g of x. Okay, so you would have f of x, right? And you'd have g of x. And what you would do is take x, you would substitute it into g of x first, and then whatever you would get out from g of x, you would substitute it into f of x. Okay, so remember, we can write this notation as f of g of x. So, like I said, we're taking whatever we get from g of x and putting it into f of x. Alright, so follow along here. And I have this kind of shown on your slides as well right here, but let's make some sense of this. So we're starting out with the x value of 1, and then it's becoming 4 when we substitute it into g of x. Or we're taking 3, and it's becoming 6 when we substitute it into g of x. Or we take 5, and it's becoming 8 when we substitute into g of x. Now, if 1 becomes 4, and 3 becomes 6, and 5 becomes 8, what must be that rule for g of x? Well, g of x would have to equal x plus 3, because we see that we're adding 1 plus 3, 3 plus 3, 5 plus 3 to get 4, 6, and 8. Okay? Well, once we get those values for g of x, we're going to substitute them then into f of x. Well, let's see. How do we get from 4 to 8, and 6 to 12, and 8 to 16? Well, we see that all those numbers are doubling. 4 to 8, 6 to 12, 8 to 16, they're all doubling. So then that would mean that f of x equals 2 times x. Okay? So what we did here was we substitute those x values into x plus 3, and then we're substituting the values that we got out from there into 2 times x. Let's get some practice with that on these problems here. Here we're given f of x equals 3x plus 1 and g of x equals x cubed. We want to find each value. So we've got this notation here. We've got f of g of 2. That's how we read that, f of g of 2. So what this is telling us that we're going to do first is we're going to substitute 2, that's the x value here, right? We're going to substitute 2 into g of x first. So I'm going to find g of 2. So I'm substituting in 2 for x, so that's going to be 2 cubed, and that's going to be 8. So we get g of 2 equals 8. So now I found g of 2, which is 8. So I'm going to say f of 8. Now I need to evaluate for f of 8. Well, f of x is 3x plus 1. So I'm going to say 3 times 8 plus 1. And that's going to give us 25. So we would write our final answer as f of g of 2 equals 25. Alright, and let's recap that. We substituted 2 in for g of x first. We got 8. We took 8 and then substituted into f of x. And we got 25 out. So f of g of 2 is 25. Now for number 2, we have g of f of 2. See how this is written differently than the first example? This is just a different notation. You need to be able to recognize this notation as well. I've seen it on ACT problems before, so be able to recognize it. Okay? So what we're going to say, we can rewrite it a different way. We can say g of f of 2. All right, so now I'm going to evaluate for f of 2. And once we get f of 2, we're going to substitute it into g of x, right? So first evaluate for f of 2. F of 2 would be 3 times 2 plus 1. So f of 2 equals 3 times 2 is 6. 6 plus 1 is 7. So f of 2 is 7. Well, what are we going to do with f of 2? What are we going to do with 7 now? Oh, yeah, that's right. We're going to substitute it into g of x. So we're going to find g of 7. X is 7 here. And so that's going to be 7 cubed. Because g of x is x cubed, we'll say 7 cubed. So g of 7 is 7 cubed is 343. So our final answer, we can say g of f of 2 as it was given to us in the notation. G of f of 2 equals 343. And there's our final answer for that. Okay? So this is just telling us that we substitute 2 into f of x, and then whatever we get out for that, we substitute it into g of x. Let's move forward. This one's going to be a little different. We don't have a number to evaluate for, do we? Instead of f of g of 2, this is f of g of x. For number 2, we're going to be finding g of f of x, not like g of f of 2 or some other number, right? So let's look at number 1. Here's how we're going to solve one like this. We're going to take f of x, and we're going to substitute g of x, the actual function, into it. Follow along with me here. So f of g of x. So wherever I see x, wherever we see x in f of x, we're actually going to substitute g of x. Because remember earlier we substituted 2 where we saw x, right? That's what we're used to. But here we're substituting the whole function. So follow along with me here. So where I see x, I'm going to substitute g of x. So we're going to say 5 times, now what is g of x? It's 2 divided by x minus 1. That's what it's saying here, 2 divided by x minus 1. And then plus 2. All right, so that's going to give us f of g of x. We're going to say 5 times 2 is 10 over x minus 1 plus 2. Now I cannot combine those things, so that's my final answer. I can't go any further with that, so I'm just going to box that. That is f of g of x. All right. So what we get out is a new function. All right, we don't get out a number answer. We're going to get out a new function. All right, now let's do number 2, g of f of x. Remember, we can write this as g of f of x. So here's the deal. Wherever I see x in g of x, I'm going to substitute the f of x equation, okay? So we've got g of f of x equals, well, I'm going to substitute f of x in g of x, right? So we're going to have 2 over wherever I see x, I'm substituting in f of x. So f of x is 5x plus 2, so where I see x, I'm substituting in 5x plus 2. And then subtracting 1. 5x plus 2 minus 1 in the denominator. Alright, so we got g of f of x equals 2 over, now can we go ahead and combine 5x plus 2 minus 1? Yes, that's going to give us 5x plus 1. 2 minus 1 is 1. We cannot simplify that any further. This is our final answer. Go ahead and box it. So I hope that video was helpful for you. If you have any questions, make note of them, rewatch the video, and come to class with them and ready to work. Good work today. Thank you, collegiate scholars.